Nathan Price. I have two roles. I'm a professor at the Buck Institute for Research on Aging, where I co-direct the Center for Human Health Span. And then I'm also Chief Science Officer for a company called Thorne, which works with about 5 million customers and about 50,000 healthcare providers in the United States. For this talk, I'm going to mostly talk about my science, and so what we're doing at the Buck. Next panel, we'll talk mostly about Thorne. So, is there a clicker? Oh, here we are. Perfect. Oh. Not starting where I thought it was. So, as we think about longevity, obviously there's this notion of where we want to get to from the standpoint of health span versus lifespan, which I think we're all very familiar with. I mean, I think one of the things that comes to mind, and certainly one that's personal for me, is if you've read, for example, Atul Gawande's book, Being Mortal, one of the best titles I feel like ever in publishing. He could have called that On the Future Characteristics of Healthcare Systems in Late Stage, United States or something, United States Healthcare or something like that. But really had one of those great moments. And it was interesting because I recall watching my grandfather and the end of his life, and in those last 3 years, really only managed to get out 4 words during those period, which were, "I want to die." And so if you think about that, and you imagine, as is discussed in this book, the end of life that so much of us envision or what we want it to be like, in 90% of cases, we have something that when we're our age now, we would say that we massively don't want. And so we have in our healthcare system, and we spend a huge fraction of our healthcare dollars on extending that last little bit of life. And so one really question you want to ask yourself is, what should we be doing in terms of advancing health span? And I was catching up on some old reading a book called The Moral Epistles. This is by Seneca. This is 2,000 years ago. And he put this in a way that I really loved, which was, for it makes a great deal of difference whether a man is lengthening his life or his death. And if we think about why we're all here in this room, is because we want to imagine medicine and healthcare and the biological enterprise and all of these different kind of things that we're doing in such a way that we can expand life rather than only focusing on extension at the end of our death. And so we want to be able to improve health span in that way. Realizing I did not attach the deck I sent that I thought I'd add. So one of the things that I want to talk about here then is, how do we do that? And the way that I think about this is something that we've called scientific wellness. So Lee Hood and I, and if you don't know, I don't know how many people know Lee. Lee won the National Medal of Science from President Obama, was the originator of the automated DNA sequencer that made the human genome possible and so forth. He and I have been partnered up and working together for 20 years actually now. And so one of the things that we got really interested in back in 2013 was around this notion that we intervene much too late, and that in fact the whole biomedical enterprise that we have is too centered on only disease and really not enough on wellness. And so we got the idea of, how could we try to take the same rigorous level of science that we apply to the study of disease and instead study health. So we've been running studies on this for about the last 12 years. Lee and I wrote a book that was a bestseller from Harvard Press a couple years ago called The Age of Scientific Wellness, that chronicles about over a decade of work in taking really dense data from people and trying to understand what goes on with their health. Back then, this was pretty new. Now we see this incredible surge behind the wellness industry that probably many of us are feeling, and an incredible surge, obviously, around longevity. This is an interesting report from Deloitte, for those who haven't seen this or read this, which forecasts about a $2 trillion shift in our $4 trillion healthcare industry from care after illness and late stage towards wellness, prevention, and longevity. And so this is really an incredible opportunity for those of us in this space as we imagine what we might be able to do as part of this $2 trillion pivot and what this might mean for the future of ourselves, our loved ones, and humanity as we think about how to restructure this in a better way. A good example of why this matters, let's take Alzheimer's disease. So this is a piece I wrote for the LA Times a couple of years ago. But basically, if you think about the problem of Alzheimer's, we have spent, and there's many estimates out there, but some hundreds of billions of dollars trying to develop late-stage drugs for Alzheimer's disease in various forms over the decades. And if you look at what we've gotten from that, the answer is remarkably little. I was one of the 3 keynote speakers at the NIH meeting on combination therapies on Alzheimer's recently, and you just couldn't help but come to notice. The first talk was a good pharma talk, really great person, great studies, good p-values, well-powered, good studied, but you couldn't help but notice that the effect sizes are tiny and the cost per patient are massive. Second talk, which was Laura Baker from West Virginia, she gave a beautiful talk on lifestyle intervention. You couldn't help but notice that the cost was small and the effect sizes were large. In fact, in certain populations, like the Hispanic population in the United States, that isn't so driven by susceptibility to ApoE4, 45% of all Alzheimer's in that population is preventable by lifestyle change. Other groups have a bunch on the table as well, but that one stands out. So part of the reason for this is because if you imagine this challenge of dealing with Alzheimer's disease, and this was one of the big misnomers in the genomics revolution, when people started getting genome tests, this must have been repeated in the press tens of thousands of times, I feel like I saw it, which is don't go get your genome measured because you'll find out you're at high risk for Alzheimer's and there's nothing you can do. Repeated ad nauseum over and over again. Totally untrue. What's meant by that is that there is no drug by which you can make a meaningful difference in late-stage Alzheimer's. For the very simple fact that when you've gotten to that point, a whole bunch of your neurons have died, billions of synapses that encode your memories and your thought processes and patterns have all gone away. The notion that you could take a small molecule and regrow all that capacity, totally fanciful in my mind. Now, prevention, which is to stop neurons from dying in the first place, radically simpler, much more tractable, much more doable. And that's what studies like the FINGER study that have showed these impacts on prevention have really enabled for us. Now, of course, this isn't really a new idea, right? This is the story we all learned, at least many of us, when we were about 3 years old. This is the story of Humpty Dumpty, right? Much easier to keep the thing from breaking than to put it back together again. So in thinking about this then, 12 years ago, Lee and I started something we called the Pioneer 100. We then started a company called Aravale, and over time we generated deep, dense data on about 5,000 people over a 4-year period. This was the first time that any large cohort of people that were just selected or not selected for any particular disease or just coming from a wellness state were deeply monitored. And so we were actually following things like we got the whole genome sequence on everybody. We measured about 1,200 clinical labs, so proteins, metabolites, different sort of measurements that your doctor might make, doing that multiple times per year, microbiomes multiple times per year, wearable devices, and all of this so that we could build actionable possibilities for what individuals could do in order to improve their wellness. And the idea is if you can run a wellness program of this type, then as a byproduct, essentially as an exhaust of people going through this, because you've got to make a difference in a person's life today. No one's really interested in the far future. We kind of talk about it, but it doesn't motivate your day-to-day behavior very much. And so by doing all that, this would enable us to create what we call personal dense dynamic data clouds, or deep phenotyping. And so you gather a lot of really interesting data as you're able to push this along. Now, what's amazing is the depth of that data, and what you can pull out of that now is radically transformed. Aravale, unfortunately, went out of business in 2019. There's a whole interesting divergence we could go into about that. Lee and I often commiserate a little bit because if we're standing here now with like 500,000 or 1 million people through this at the birth of AI, we'd be in a completely different world. But the point is that these new AI systems allow us to do a couple of really powerful things. One is that we can dive in and understand what's going on in the data at a much deeper level. And the second big element, and I'll talk about more of these in a little more detail, is that we can deliver personalization and insights powered by an incredible complexity in a level that we could not even fathom a few years ago, right? And these things are advancing incredibly rapidly. Yeah, I attached the wrong one here. This is a way longer talk. So this is, yeah, apologies for that. I don't know how I did that. Anyway, so all of the data that I just skipped through, because this is only a 10-minute talk, so I can't go through it, but I'll just give a brief summary. So some of the things that we were able to learn on these kind of data, and we've published about 25 papers in various nature journals and so forth, that show things like that the ability for you in a lifestyle program to lower LDL cholesterol, turns out that who can do that and who can't, you can predict from the genome. If your microbiome will predict a certain subset of people will get double the lowering on a statin of LDL cholesterol compared to people on different types of microbiomes. We've clustered this into 4 groups. 2 groups of microbiomes show a transition towards diabetes on statins. The others don't. A 9% increase in the rate of diabetes is a known side effect of a statin. Weight loss, the only thing that was predictive in all the massive amount of data we gathered for weight loss, gene content of the microbiome. In particular, how much short-chain fatty acids you made in your microbiome. Butyrate being one of those actually is stimulatory to GLP-1. Didn't know that at the time. I wasn't into that. Of course, we all know that now because it's become such a huge area. Biological age, we showed that in the cohort you could get a negative 0.16 years per year change in biological age over time, just based on a measurement. We could go into that in more detail, and on and on. So you can get into many, many different types of discoveries. These are all published in Nature Biotechnology, Nature Medicine, Nature Aging, Nature Metabolism, PNAS, things like this. So we can go through a whole bunch of different discoveries. So to close, though, in the short talk, I'll just mention these 3 big areas that we're working on at the Buck, where my lab is completely focused on AI and the application to big data. I will say that we've got a new partnership with the UAE, so we're getting involved with their Million Genome Project. A lot of people out there. We've got elements here around scientific wellness and deep phenotyping, as I mentioned. We're building out something we call the Personalized Health Span Optimizer, or the N of 1 Analyzer. Got a $52 million award from ARPA-H that's allowing us to build that out at scale. That's asking the interesting question, which is not just comparing population A to population B, but what can you say when you have millions of data points on one single individual? And how do you think about that and interpret that? We've been thinking about this and working on it for a long time. Very, very hand-wavy and hard to think about until you get the new AI tools of today, which make this possible. And then the final thing I'll mention is this thing that I'll call the virtual systems biologist, which is we've now built an AI system, the first prototype, that takes that elements of what we did in those 25 Nature Journal papers that I mentioned, of taking a question, applying it into tons of this deep data, running analysis. So what the virtual systems biologist does is it mimics that entire process. So we have the first working prototype of this, but it will take, it will analyze against all those dense data we gathered. You can ask it a question. It will generate an analysis plan, execute the analysis plan, make the figures so that you can look at them, write the paper, and do that. And what we're doing now is building additional layers on top of that so that we can evaluate insight, evaluate the level to which it's novel, and we can automate this in processes. In fact, we have this kind of joke metric in the lab, which is how fast can we redo John's 7-year thesis. And we're getting close to the, we've gone from months to weeks to days to hours, maybe minutes, eventually. So these things can scale incredibly fast. And with that, I'll end, and that's some of the work we're doing at the Buck.